As my friend would say, let's get the teaching started. You're welcome to another episode of AI for Humans. And today we are going to be discussing about the loss function. Or let's stop that. Forget about this for now. We are going to discuss AI's report card. And yep, AI has a report card. Okay, so what exactly is the report card of AI and how does it even matter, especially in training artificial intelligence? And don't forget where we are coming from. We're saying for your AI systems like ChatGPT and Claude to give you good answers, they need to be trained or taught what the good answer actually is. And that's a process, right? And sometimes you notice that your systems are giving you bad answers. You ask ChatGPT a question, it gives you a wrong answer. How many hours are in strawberry? It doesn't calculate that very well. Why is it making those mistakes? Well, it all comes back down to training. So the report card system is a system that actually helps the AI or the machine in this case, as we always describe it, to be able to answer questions efficiently by try and error. Remember last week we discussed that AI goes through a loop. And if I can find that loop properly here, so although my notes may be messy, we said AI always does what? It would guess, it would check, it would error, and it would adjust. This checking here is the report card system that we want to implement. So what exactly do we mean? Let's use a very good example. When you were in school and you wrote your exams, at the end of the school year, imagine if you go to school and your teacher just wrote on your report card and he said grade. And he said, what's your grade? And the teacher just wrote good. Or the teacher wrote bad. And that's it. Know whether you came first, second, third. No percentages like, oh, maybe you had 70%, 80%. Teacher doesn't write that. It just says good or bad. Right? I mean, the lazy GSS to me would be grateful because my result wasn't always a good thing to take home. But apparently, this doesn't tell you a lot. This doesn't give you a lot of information. This doesn't tell you whether how well you should improve or whether you did very well at the end of the semester or there's some other areas that you could work on. But when you actually check your results, you'd see that most times it will come in the mode where you'll be told that in math, you scored 70%. Maybe in English, you scored 60%. Maybe in French, you scored 45%. You are giving grades. Now pay attention to this. We know that the overall percentage is what? 100%, right? We know that. So what inadvertently, what we are telling you is that you were 30% away from the score. You were 40% away from the score, and you were 55% away from accurate score. This is a report card system. And this number did not just tell you how wrong you are, it helps you to know where to focus. So now you could go back into your script and you say, oh, I failed this question, I failed this question, I failed this question. What were the answers? Right? That's the idea. That's the essence of these gaps that you have in the system. That's why you are given these percentages to be able to rectify. AI has the same thing. AI works the same way. When AI makes a guess, and in this case, we're going to call our guess prediction. Whenever AI makes a guess, something scores it, right? Remember we said that AI is trained on scores of data, lots of data sets, right? Encyclopedias, websites, many things. It is trained on it. Now, imagine that training section where we are feeding the data into AI, like when you go to your classroom every day to go and learn from your teacher, right? AI is giving the training section. It has all of that information. It has gone to class. Now, how do we test your knowledge? You write an exam. In the same way, AI models, and now I'm using these terms because I believe you're following through. AI models, now it has been trained. The AI model is like a retention. So the model here, remember we said the model is a file. that holds all the connections between words together. The model here now takes all of the training that it has received and then would give it a test. You say, based on what you have learned, come and tell us if what we taught you is correct. So if every time in the data we taught the AI that 2 plus 2 is 4, we'll come back here and ask it 3 plus 3. Why? Because remember, we are not memorizing, we are learning patterns. So we want to know, did you learn the pattern correctly? We already know that the answer to this question is 6, but we do not tell the AI, we don't show the AI the answer. The same way nobody will show you the answer in exams. We know that the answer is 6. So when the AI gives us a response, and we say 3 plus 3, if it tells us 6, we say good, correct, you've done a great job. If it tells us 5, then we compare 5 with 6, and we say you are missing by a difference of 1. This is what we call the loss function. Now, ideally, it's a mathematical calculation that happens in there, right? But this number here is what we call the loss. All right? This is what we call the loss. And again, intuition. This is not the full breakdown in terms of code and math, but you're getting the idea of what we call loss. And why are we calling it a report card? It's because it helps AI to know how far away it is from the answer. Let's make this a bit easier. Let us look at another example. And I don't know if you've ever played with a dartboard before, but let's imagine that this is a dartboard, right? You know how dartboards are, they have different sections until you hit bullseye. So your aim is to shoot arrows at this. So let's say you have 5 arrows. You can shoot 5 arrows at this, right? I'll give you a chance to shoot 5 arrows. When you shoot your first arrow, it landed here. It landed here. This is arrow 1. Now, after shooting at that point, remember that this is the aim. This is our aim. You shot your first arrow there, it landed at that point. Then you say, oh, okay. I think I'm going to position my hand lower. Why? Because you are calculating, back of your mind, you are calculating what is the distance between this point and this point. You do a little bit of mental math and you're like, okay, if I drop my hands by a few meters and I hit it again, I should be able to hit the aim. You try again and you probably hit this point. And you're like, oh, yeah, now I'm closer. Let me try again. You try again and probably you hit this point. You're like, I'm closer, but I'm a bit farther. Let me adjust. And you keep shooting until if eventually you hit bullseye. What has happened here is that when you hit aim number 1, you discover that your loss from the aim was very high. Okay? Your loss, like, oh, wow, compared to what I'm aiming for, this is not even close at all. You tried again, but this time your loss from the aim, oh my God, this is actually looking very messy. Your loss from the aim reduced, and your loss continued to reduce until your loss became 0. All right? And that's what happens. So whenever we're training machines, every training cycle, every time we feed it data and we train it and we train it and we train it and we give it questions and we expect it to answer the questions, it begins to look at it and it's the focus on it is how far away am I from the actual answer? How far away am I from the actual answer? Now, let me give you a real life example, right? Just so you can, and I believe this will drive you home even much better, okay? Let's imagine that we're training an AI to predict house prices. And we say, okay, this is the data set. This is the data set, and we want you to predict. I believe at this point you get it, but just to make it so clear, you're training an AI to predict house prices, and we teach the AI that houses in Lagos. We don't tell the AI anyways. We just feed the data. We say houses in Lagos. So there's mainland, there's island, there's no land, and there's the other land. And we say, okay, so let's imagine that for the mainland, we give it 8,000 houses, same as the island, same as the no land, same as the other land, right? 8,000 houses each. And we say on the mainland, the average house price is, let's say, 50 million. On the island, 100 million. In no land, 150 million. Let's give low land some hype. And in the other land is 10 million. Now, we have trained it on 8,000 places. So in these 8,000 places, we're showing you places like Ikotsun, Yaba, Obalende is not on the mainland. But, we gave it all of those examples and we gave it prices, but this is the average price, right? So AI has 8,000 examples times 4. Good. Now I've given you so many examples. How well did you understand it? Now let's ask you some questions to see whether you are very good at predicting house prices. So what do? We come and we say, hi, ChatGPT or whatever, what is the price of a house? What is the likely price of a house in Ikotsun? If AI comes back and tells us that the price of a house in Ikotsun is 80 million, we're going to say, not really, because houses on the mainland, 50 million on average. I mean, it might be right, but let's just pretend like it is not supposed to go beyond 60 million. I would say houses on the mainland are actually around 50 million. So why are you predicting 80 million? I would say, oh, look, houses on the mainland should be around 50 million. And you're like, okay, so what is my loss? How far off am I from this? I'm like, okay, 30 M. So now say, okay, go back into the data, train yourself again, look at the full data again, try to understand it properly and come back and give us that. Now, what if it comes back again and it tells us, now I believe the house in Ikotun is supposed to be around 70 million. We therefore say, accuracy has increased, right? We say accuracy has increased. So now you're getting a bit more accurate. Here we can say maybe you're like 20% accurate. And here we'll say, okay, I think it has become 30% accurate. I will say, okay, accuracy has increased, but it is not 100%, which means it is not very accurate. And we'll say, okay, try again, right? If it comes back the third time and it says, the house in Ikotun is around 45 million. Like, oh, now you're getting somewhere, right? Compared to 15 million, you are becoming really accurate as maybe at this point we'll say you're like 80% accurate. You get the idea. So you see all of this stuff we're doing, retraining in AI, in data science, it is called, just give me a moment, because this is one concept that you have to pay attention to. It's called minimizing the loss. So we keep trying to minimize the loss. And the loss in this case is the difference between actual and predicted value. Okay? So it's like, what is the actual value? What is the actual answer? And what is the predicted answer? The difference between them is the loss. Now, mathematically, again, I'm saying this is intuition. When we get into the code, I'll get into the math, it's a lot more complicated to calculate, but this is the base idea. When you know this, you cannot even fail when it comes to the course, when it comes to the code, or when it comes to the math. Now, here's why this concept matters beyond technical detail. This is why you need to think of it beyond all the AI jargon that you read out there. It's because when you change the loss function, you're changing what the machine essentially cares about. You're changing what the machine essentially defines as wrong. And this is something that is very crucial in training AI because, training machine learning, because you cannot generalize a loss function. So imagine we're training an AI system, right? On how to, and the system is goal. The aim of this system, let's give me a moment. The aim of this system is to detect breast cancer. Actually, systems that do this, right? So when they see signs of, then they see symptoms of breast cancer, they can tell you if it is malignant or if it is benign. Now, the aim of this system is to detect breast cancer, right? And we have another system that its aim is to detect whether, the aim of the system is to detect whether, let's say, detect whether a house would collapse in 2 years or in 5 years. You see, the two systems here are very different architectures. Their loss function is different. Their training is different. And why their training is different, because we are talking about things that matter here. Breast cancer is a very delicate issue, right? And so if we are going to train this AI system on maybe what 1,000 data points, we might be training this AI system on 1 million or even 10 million data points, because in this scenario, accuracy is a very, very, very high point. Whereas in this scenario, if the AI says 2.5 instead of 2, maybe not much of a trade-off, maybe not much of a bad idea. But here we cannot say a person is benign when it's actually malignant. And by benign here, I mean like, a person is at risk, but we say, oh, the person is not at risk. Whereas the person is at risk. We cannot make that kind of mistake compared to this situation. And this is where AI ethics counts, because when it comes to accuracy, somebody has to make a decision of how far from accurate can we be. Somebody has to say, okay, when it comes to this building now and the fact that it can collapse, right? How accurate can 80% accuracy be good enough for the industry, or should we go as high as 90% accuracy, right? Somebody has to make this decision, because the tendency of your AI system or your machine learning system being wrong can put lives at risk. So this is when we talk about AI ethics and AI decision making. This is where it shapes a lot of things. I don't want to go into that, but I just wanted to bring that out. That if you work in the machine learning space, you need to consider a lot of things before you even go down into training. What is the effect of this data set that I'm working with? Who is it going to affect? What does false predictions, what does it mean for the end user, right? All of these things you want to consider as an AI engineer, as a machine learning engineer. So what have we learned so far? Well, if we have a big loss, our aim is to make it small, right? And what do we do to make it small? We train, right? We ask ourselves, how far is the loss from the accurate result, right? If our accurate result is 10 and our loss is 3, so it means we probably got 7. And okay, how close can we get to 10, right? That's the idea here. And remember that it is, when we talk about training is the aim of training. The main aim of training data, like we'll be talking about training since episode 1, is that we want to make loss as small as possible, reduce loss to the smallest possible, to the barest minimum. And what exactly that means is going to be dependent on the situation at which you are working. Now, what about a situation where we don't give AI a report card? We say no answers. We don't have the answer. We're going to feed you data, take all the data and figure it out on your own. This is where AI gets very interesting. And that's going to be our next episode, where we talk about unsupervised learning. It's more like learning without supervision. So we're not telling you, are you right or wrong? We want you to figure out the core. And I'll see you next time for that episode.